Look at the keyboard in front of you. You probably haven't thought about it since the day you pulled it out of the box, or the day your IT department dropped it on your desk. It's flat, it's cheap, it's plastic, and it gets the job done. Now, what if I told you there is a massive global community of highly functional, otherwise financially responsible adults who will happily spend the equivalent of a monthly car payment on a single keyboard, and then they'll spend another $100 on custom colorful plastic squares just to put on top of it. Oh, and it gets better. These same people will literally spend their Friday nights huddled over a desk with a pair of tweezers and a microscopic paintbrush, meticulously lubricating 100 individual plastic stems with aviation-grade grease, just to make their spacebar sound slightly deeper. Then, they'll log onto the internet and argue for hours about the acoustic resonance of polycarbonate versus aircraft-grade aluminum. If you're looking at this from the outside, it sounds like absolute certified madness. It sounds like a highly specific cult for typists. But I promise you, beneath the obsession, the weird jargon, and the eye-watering price tags, there is a genuinely fascinating world of physics, material science, and human ergonomics at play here. Today, we're going to dive into the exact mechanics of why these heavy, expensive rectangles are so wildly addictive, and why. Once your fingers experience the science of a custom, switch your wallet is basically doomed. Let's break it down. For the vast majority of computer users, typing happens on what is known in the industry as a membrane keyboard. If you were using a standard office-issued Dell or a laptop, this is exactly what you are torturing your hands with. Underneath those flat, lifeless plastic squares sits a single, continuous sheet of silicone or rubber, covered in little domes. When you press a key, you are physically squishing that rubber dome down until it forces a tiny conductive pad to hit a printed circuit board underneath. That impact completes an electrical circuit, which tells your computer, hey, he pressed the letter E. Because you are essentially just mashing down on a piece of squishy rubber, the physical sensation is terrible. There is no distinct mechanical moment where the key actually registers. Because of this fatal design flaw, your brain doesn't know the letter has been typed until you push the key all the way down to the absolute bottom of its travel distance. We call this bottoming out. Over an 8-hour workday, your fingers are basically experiencing thousands of tiny car crashes. You are constantly slamming bone and tendon into a hard plastic base, transferring that impact shock right back up into your wrists. It is an incredibly cheap way to manufacture a million keyboards, but from an engineering and biomechanical standpoint, it's garbage. A mechanical keyboard throws this rubber dome nonsense directly into the trash. Instead of a single mushy sheet, every single key on a mechanical keyboard is its own independent, self-contained mechanical switch. Inside that switch is a plastic stem, a high-quality coiled steel spring, and tiny metallic contact leaves. When you press a mechanical key, you are not fighting a piece of rubber. You are compressing a precision-engineered spring. The absolute magic of this design is that the key registers its press halfway through its downward journey, long before the key physically hits the bottom of the board. The exact microsecond those metal contacts touch, the letter appears on your screen. You do not have to bottom out. It's exactly like the difference between driving a sluggish, worn-out automatic car and a crisp manual transmission. When you throw a manual into third gear, you physically feel the mechanics engage. You don't have to guess. That tactile feedback instantly tells your brain, we are in gear. That precise physical confirmation is exactly what a mechanical switch restores to your digital workspace. Depending on the specific switch you choose, a mechanical keyboard will actually talk back to your fingers. In this rabbit hole, the engineering of these switches falls into 3 primary families: linears, tactiles, and clickies. Linear switches are completely smooth. The force curve is a straight line. There is no physical bump. It is a pure, frictionless slide from top to bottom. Gamers love these because there is zero mechanical resistance when you are frantically mashing the spacebar to avoid getting sniped. Tactile switches feature an engineered bump on the plastic stem right at the exact millimeter where the key actuates. As you press down, you feel a slight resistance, like a tiny mechanical hill. The second your finger crosses the crest of that hill, the key registers. You don't even need to look at your monitor to know you typed a letter. Your central nervous system felt the mechanism engage. Then, there are the clickies. Clicky switches take that tactile bump and add a tiny secondary mechanism that intentionally snaps downward to produce a sharp, metallic click. It feels exactly like an old-school typewriter. It is also aggressively, obnoxiously loud. If your primary goal in life is to ensure your wife actively resents her hobbies and your 6-year-old daughter never, ever sleeps through nap time again, buy a board with blue Clicky switches. You will feel incredibly productive, but your entire family will want to unplug your computer and throw it out the window. This brings us to the most ridiculous yet fascinating part of the hobby, the acoustics. To the uninitiated, all mechanical keyboards just sound loud. But to the enthusiast, tuning the acoustic profile of a keyboard is treated with the same seriousness as tuning a Steinway piano. In this community, you will constantly hear two completely made-up words used with absolute, deadpan sincerity: clack and thock. A clacking keyboard has a higher-pitched, crisp, energetic sound, like heavy mahjong tiles snapping together. A thocking keyboard, however, is the holy grail. It is a deep, rich, low-frequency acoustic pop. It sounds like heavy raindrops hitting a hollow wooden deck, or thick glass marbles rolling into each other. It is auditory chocolate. Achieving that perfect thock is a masterclass in over-engineering. Enthusiasts will spend hours tearing their keyboards apart. They will inject thick aviation-grade lubricants into the plastic stabilizers so the spacebar doesn't rattle. They will swap out standard metal plates for softer polycarbonate ones to absorb vibrations. They will literally stuff the bottom of their $300 aluminum cases with acoustic dampening foam or poured silicone just to absorb unwanted high-frequency sound waves. They turn a boring data entry tool into a carefully tuned acoustic instrument. And we cannot talk about custom keyboards without talking about the keycaps themselves. This is an entire subculture all on its own, heavily rooted in material science. Most cheap keyboards use ABS plastic. ABS is lightweight, easy to mold, and incredibly cheap. But it has a fatal flaw. Over time, the friction and natural oils from your fingers essentially polish the plastic. Within a few months, your spacebar and your frequently used gaming keys start looking like a greasy slice of pizza. Enthusiasts despise the shine, so they upgrade to PBT plastic. PBT is a much denser, far more durable polymer. It has a rougher, textured, matte feel that resists that oily shine for years. It fundamentally changes how the board feels under your fingertips and slightly lowers the acoustic pitch for maximum thock. But it doesn't stop at just the material. The keycap community is heavily driven by independent designers who release limited edition colorways. You want keycaps inspired by 1980s NASA mainframes? A minimalist, brutalist architecture set? A set that perfectly matches the color code of a vintage Ferrari? They exist. And because they are manufactured using complex double-shot injection molding, where the letter is actually a separate, solid piece of plastic baked inside the keycap so it never fades, these sets can easily cost upwards of $150 for pieces of plastic that you punch. And honestly, it works. It turns out that when you take the most frequent physical point of contact you have with your digital life, and you stop treating it like a disposable napkin, your entire relationship with your work changes. When you don't have to bottom out your keystrokes, your repetitive strain plummets. When you upgrade from cheap ABS to dense PBT, your fingers don't slip. When you have a machine that weighs 5 pounds because it is CNC machined from a solid block of aluminum, it doesn't slide around your desk when you type aggressively. We live in a world where we stare through locked-down, standardized glass screens to manipulate abstract data. You can't change the hardware of your smartphone or your laptop. But a custom keyboard is a completely open sandbox. You chose the weight of the steel springs. You tuned the acoustics of the case. You built the workspace. So yes, dropping the equivalent of a car payment on a keyboard seems completely unhinged. But once you experience the physics of a truly great one, once you feel that tactile bump and hear that deep, satisfying thock, going back to a rubber membrane feels like typing in mud. And honestly, life is just too short to type on a wet sponge. Anyway, my daughter is trying to sleep, and I need to go apologize to my wife for the sound of my blue switches again. Drop a like if you learned something, throw your mushy membrane keyboard in the trash, and I am Sal. I'll see you in the next deep dive.